So let's go into the next one right now. Problem number 2 says, during a 3-second time interval, a runner's position changes from 50 meters to 30.5 meters. What is the runner's average velocity? Okay, well, let's think about this here. It says, during a 3-second time interval, the runner's position changes from this to this. Okay, well, what does this 3 seconds represent? Oh, hopefully you're saying that that's our delta t. And what does this 50 meters represent? What is that telling us? Oh, that's where he's starting. That's the initial position of the runner. And what about this 30.5 meters? Well, that's where he's ending up, right? Or she, or whatever the sex is of the runner. And it's asking us, what is the runner's average velocity? Oh, that's what we're trying to find. How about that? So, and once again, just to really clarify this, the position is going to be measured in meters. We do have time measured in seconds, and our velocity, the units should be meters per second. So once again, we do know that we're trying to find the runner's average velocity. Which formulas do we want to use? 1, 2, 3, 4, 5, or 6? Hopefully you're saying formulas 1 or 2, being that those are the ones that have to do with average velocity. And are we given our initial velocity and final velocity? No, but we are given the initial position and final position. So therefore, hopefully you're saying, hey, you know what? We have initial and final position in equation number 1. Let's use that. All right, and all we have to do is plug in. Oh, this is simple enough because we actually have the variable that we're looking for on the left-hand side of the equation by itself already. So all we're going to have to do is take this, plug it into the calculator, and we'll get our answer. So we have our final position, which is our 30.5, minus our initial position of 50, and we divide that by 3. And when we plug this in the calculator, we'll get an answer of, wow, this is a negative number. 6.5, and our units, which our calculator won't tell us, but we do know it because we know that every velocity gets measured in meters per second when we're dealing with meters and seconds. Okay, so this is our answer. Now, you might be saying to yourself, oh, wait a minute, why is it negative? What's going on there? Well, okay, so thinking about this, say if we look at this problem, look as if it's on a number line, where we have a 0 over here, and we're going across the x-axis. Well, our position initially is at 50, and we're going to 30.5. That's what the runner is doing, right? So the runner is going backwards. What do you think that negative represents? Oh, that's the direction. Because of velocity, it's a vector, and vectors have both magnitude and direction. That negative is representing our direction.